going to take everything that we have learned and we're going to start actually applying it to have some use. So get out your calculators. Those of you who have your graphing calculators, and practice graphing some of these things. If you have a window of just -10, +10, -10, +10, you'll be good. No, I don't got another one. Why don't you just bring it every time?
I got just like the normal stuff.
That won't work. You need to graph it. Pardon? Yeah, we'll do one like today. We didn't do one like yesterday, so. What are we talking about? Graph it in your calculator. You should get something that looks like that for that one. The next one should look like this. Like that. What's up? We'll talk about it. We'll talk about all these. We're just practicing graphing right now. You should be able to get all those things in.
How did I miss that? Yes.
Okay, those should be all of your graphs. If you're practicing it on your calculator, you should be able to get all of these different ones.
I'll probably get up to this again.
Take it out of the window. So you go window. Your X max, you want to
Okay, because I'm going to say one thing,
yeah.
and then I don't.
Okay, let's take a look at some of these graphs. Let's look at the first one. It's going up at a pretty decent rate. Where's the Y-intercept? So that's 0. If you look at your graph on your calculator, you should see it's right about there, right about 1. And it's going upwards. Let's look at the second one. It's going downwards. And it's going down at a pretty quick steepness, right? That's all slope is how steep something is. And where's the Y-intercept? Right about 3. So you should start to see a couple trends here. The Y-intercept is it's that constant number that's kind of hanging out at the back. Yeah, Joe? Yeah, the Y value always is the last number right there when it's in this type of form. So what do you think the Y-intercept is for this one?
1.
1. We don't even really need to look at our calculator to figure out where it is. It's 1. What do you think the Y-intercept is of the next one? Yeah, it's -3. Sure, it's x squared, and we're not used to seeing x squareds. But the Y-intercept is still the same. It's that extra constant number on the back. This one over here, 1 divided by x. is a weird looking number, right?
Did we go over that?
No, it actually doesn't, so it's pretty poor. Pretty poor drawing. Should've been like,
So this is one way.
yeah, it's kind of the same little U, and it never actually touches in there. Because x can't equal 0. You can't divide by 0. But as x gets bigger and bigger and bigger, your y value gets smaller and smaller and smaller. What would be the x-intercept? We wouldn't have one. There's no constant over here. We would never actually get to 0. So that's kind of a unique little drawing. What about y? What's the y-intercept going to be? Matthew? -2. Yep. How about this next one? There is no constant. So what's the y-intercept? Nothing? Look at the graph. It crosses. It's 0. So that should be right there. 0. You're right. There's nothing there. There is no constant. But if there's no constant, it's like you're adding 0. And then the next one is also kind of a unique one. 2 to the power of x. And what is the y-intercept of that? 1. But that's not in any form we're used to seeing, which is why it's so weird. Same with this one here, right? So the trick is recognizing that every time you have something in this form, where there's some number times x plus some number, that b value is always your y-intercept. Let's take a look at this letter M a little closer. When M is positive, which way is our thing going? Up. How about when M turned to negative? It was going down. M is positive, it's going up. M is negative, working its way down. So what do you think that M represents? Rise over run, which is also known as slope. So the M value is your slope. Whatever comes before the x is your slope. Whatever you add on after is your y-intercept. Just watch. So if you look at the bottom, it asks you to list all these graphs as either linear or non-linear. Which ones are linear? Someone give me an example of one of the linear ones. Josh. First one is, what's another one? Emily. Second one, what's a non-linear one? Jared, give me a non-linear one. Which one? You think this one is non-linear? Yeah. Linear just means it's going up or down at the exact same rate. The easiest way to tell if it's linear or not is this right here. If those numbers aren't 1, it's not going to be linear. And if you see something crazy like divided by x or to the power of x, we never deal with those type of things. So that's definitely not linear. You can always graph it when in doubt to see if it's linear or not. The equation y equals mx plus b. Skip the slide. Oh, no, that was the, so if you look back, it was on the bottom. That's why we talked about which ones were linear and which ones weren't linear. Sorry. So this is actually slide 3 on your guys' now. the equation y equals mx plus b. We have a special name for it. It's the slope-intercept equation. I think that's actually even the name of our lesson. Yep, slope-intercept form. It's the actual name of the lesson, so it already gives it to you. So if you see anything in y equals mx plus b, we call it the slope-intercept form. Because the first number is giving you the slope, and the second one is giving you your y-intercept. Pretty creative name. What does M represent, Braden? What does it represent, Matthew?
Slope.
The slope. What does the B represent, Anna? The y-intercept. So you can actually graph these things pretty easily by hand. Or you can actually take a graph and figure out the equation pretty easily by hand. So let's take a look at an example. You've got an equation. 2x plus 1. This line right here. What's the slope of it? 2? How did you know that so easily? Because it's in front of the x, it's the m value. So now we have a third way of figuring out slope. We can just look at that form and know. What's the y-intercept? For 2x plus 1. The y-intercept is just 1. Look at the graph. You can even look at the graph and see that it's at 1. Or you can just look at the equation and understand that it's 1. Matthew?
If it has more than y-intercept, you can write it out.
It wouldn't be in this form if it had more than one y-intercept. That's a good question, though. Josh? Yeah, so it would mean for every 2 you go up, you go over 1. So we went up 2, the rise was 2, and the run was 1.
So it's just like just one number that looks like the rise.
Yeah, exactly. That's exactly what it means. It just means it's that number divided by 1. Let's look at this one. What's the slope of that one then? Reese. The slope of this one. Look at the equation. Which number gives us our slope? The negative 5 over 2. So then, Keith, which number would be our y-intercept? Negative 3. Exactly. That's how easy this is going to get. Maya? Oh, okay. Determine the slope in the y-intercept. Is that actually the next question for you? Yeah. So go to the next slide on your guys' page. And it says, determine the slope in the y-intercept for each of the graphs below. Michael, for A, what's the slope? The slope is always whatever the m value is. So what would the slope be for A? Your name's not Michael. 3, yep. What would be the y-intercept, Johnny? 2. For B, what's your slope, Maya, for B? Negative 0.5. So notice that they flipped where the mx and the b are. All they've done is they've rewritten it as b minus mx. So yeah, Maya's right, the slope is negative 0.5. So what would be the y-intercept time of B? 7. 7 would be your y-intercept. For C, C's trickier. What's your y-intercept? What is it, Maya? Close. Not -1. It's not 6. It's not 8. Here's the problem we have. We have it 6y is equal to 8x plus 1. It's 1 over 6. Because there's a 6 over here. And our form always comes in just y equals mx plus b. Pardon? I'm sorry, I couldn't hear you.
Whenever this is on the other side of equal sign, is it always over a 1?
Yeah, so you can just pretend it's over a 1. Like you're saying on this side of the equal sign. Like right now it's just...
Because the 6 is saying we can... Well, the 6 or 6 of the So is that always over 1?
Not always. Not always, I see what you're saying. So... Yeah, you're asking if it's always... Like if it's always going to be 1 over 6. Yeah, no, it wouldn't always be. It has to do with whatever this is, right?
Oh, yeah. So say if that was a 3, it would be 3 over 6.
Yeah, that's exactly it. If it was a 3, it would be 3 over 6. Yeah. So what you have to do is you have to divide that 6 to the other side. So that you have it as y is equal to 8x divided by 6 plus 1 over 6. And that's what you're asking. Yeah. So now, what is your y-intercept, Matthew? 1 over 6. And your x-intercept is, or your slope is what? 8 over 6. Perfect. What's up, Matt?
You just gotta do algebra to get rid of the 6.
Right. You got to get rid of that 6 because our form has to be in y equals, not 6y equals. Consider the equation y equals 2x minus 5. What's the slope? How did you know it was 2, Emma? Oh, who said 2? Josh, who just blurts out answers all the time. How do you know it's 2? It happens. Because it's attached to the x. It's our m value. What would be the y-intercept, Jared? -5. And that's a good question. It's -5. Whatever the sign is, dictates if it's positive or negative. Mark the y-intercept on the grid. Oh, that's easy. Right there. Use the y-intercept and the slope formula, rise divided by run, to mark 3 other points on the grid. They have to be exact points. So if we start at the y-intercept, we know it's right there. And we know the slope is 2. So go over 1, up 2, there's another point. Go over 1, up 2, there's another point. Over 1, up 2, there's another point. And you have to actually label those points out. So what would be the coordinates of this first point? It would be 1, -3. The x goes first, the y goes second. The next point would be 2, -1. And the next point would be 3, 1. Does that make sense? Easy? Good. Time, that makes sense? It's really confusing on where the x and the y axes are? No, that's okay, because you're not alone. There's no way you're alone. So what's the question?
I just do something because there's no line. I just got really.
You have the line. We don't have line.
You guys don't have a line?
Clay dry.
Okay, yeah. So you guys, what you guys can do,
Are you serious?
yeah. What you're going to have to do is you're going to have to learn how to draw these things. Which means take the y-intercept. That's always your first given point.
And then you just
Right here. So I won't go so fast. I'll go slower.
the slope is changed with those functions.
Yeah, I know you have. Other people don't, right? So they gotta go. Yeah. So we know the y-intercept, right? So we mark the y-intercept down. But you can't draw a graph based on one point. So you need to find a second point. To find the second point, you have to use the slope. And what's our slope for this equation? 2. A slope of 2 is equal to the rise over the run. That's all slope is, right? Slope is just rise over run. And Josh, what did you tell us earlier about if it was just 2? What does that mean the run is?
The run is 1.
Right, because if it's just 2, it's like it's divided by 1. So from that point, just follow your slope. It says go 1 to the right and go 2 up. And that'll be your next point on the graph. 1 to the right, 2 up.
Oh.
And you should have a second point right there. Now you can draw a beautiful straight line because you got 2 points. I didn't realize you guys didn't have the graph for this one. I thought the next one we had the graph. Yeah, I had the line, yeah, sorry. The next one I know you have to do too, yeah. I thought it was just the second one you had to do, not the first one. Does that make sense? Okay. Verify the graph using your calculator. If you punch that in your calculator, you should see the exact same line. Alright. Consider this equation. What's the y-intercept, Brayden? Yeah, it's 0, -6. And it says determine the x-intercept algebraically. Yeah, what? That's fair. That's a fair question. So if you have this equation, how do you find x-intercepts? Do you switch x to be equal 0? Or what do you switch to equal 0, Taylor?
Y.
Y is equal to 0 to find the x-intercept. That would be considered algebraically. So solving it out is algebra. So set y is equal to 0, and then solve it from there.
This is why.
No, I already stated the y-intercept, yeah. Next one was determine x-intercept. You're going to have to move the 6 over. Let's slide down here. So 6 is equal to 2 over 3x. I'm going to multiply by 3 and then divide by 2. Okay. 6 times 3 divided by 2 is equal to x. If you punch that into your calculator, you should get that 9 is equal to x. So if I have a fraction times x, Dawson, to get rid of a fraction times x, I take the bottom number and I multiply it up. I take the top number and I divide it down. I like saying Dawson because then you both of them. Then you're both in the same spot, so you don't know which one of them I actually want to talk to. It's perfect. Finally, you got a joke. Okay. Part C. Mark the x and the y-intercept. So, you guys on your graph don't actually have the graph yet, so you should write your dots in. The y-intercept was down here at 0, -6. And the x-intercept is up here at 9, 0. And then just connect those dots, and you have your graph. So that's a second way to figure out how to draw graphs when given the equation. I've got some terrible news for you guys. You're not allowed to use your calculators when you hit grade 12 for this kind of stuff. So, don't rely on your calculators. If it says determine something algebraically, you have to show your steps. You have to. And that's what you're going to see. You're going to see show algebraically. And if your graph doesn't match what you did algebraically, you get it wrong. So if you did it all algebraically and you got the wrong x-intercept, say you got x was equal to 7, and you put your dot over here by accident, and you drew that line, I'm not going to give you the mark here, but I am going to give you the mark here, because you drew it right considering what you thought was the right answer. But if you figure it out algebraically wrong, and then you used your calculator to figure out the graph right, you're not going to get either mark. Because I know that you used your calculator to graph it, and we don't want you to use your calculator to graph it. So you're better off just doing it algebraically and getting 50% than taking 0%. Does that make sense? Verify the graphing intercepts using your graphing calculator. If you punched it in, it would look just like that.
Sorry, when I wanted
To verify you're good, yeah. So, and that's why it says, that's why it says as the last part, because you should always just check to see if you got it right. Like, there's nothing wrong with checking on your calculator to see if you got it right. If you got x equals 7 and you look at your graph in the calculator, it's like it's supposed to be 9, you screwed up somewhere. Go back and fix it. That's all it is. Any questions on how we use slope, intercept, form? All right, flip it over. And you got a whole bunch of it. Slide on. What's your next slide? Is it the, yeah, okay, good. There's a nice little slide talking about what you can do. If you flip it over, there's even more ways to practice. That's for you guys. We don't need to go over it together. It's just if you need notes when you're looking back and studying. All right. We're going to